All right, this is the calorimetry lab. We are going to be collecting data to identify unknown metal cube number 2. So this is unknown metal cube number 2 in that beaker of boiling water right now. I'm going to go through and collect the data. As I collect the data, you follow along, record those numbers in your data table, and then use those numbers to do the math, find the specific heat of that metal, and use it to identify that metal. First thing I'm going to do is get the mass of the calorimeter water. So this is our calorimeter right here. It's just an insulated container. I want to know the mass of the water, the initial water that's going in there. I have here 2 graduate cylinders. This one has, they actually each have exactly 100.0 milliliters of water, which means we have a total of 200.0 milliliters. And because the density of water is 1 gram per milliliter, I know that 200.0 milliliters of water is going to be 200.0 grams of water. So that is the mass of calorimeter water, 200.0 grams. Next thing I want to do is take the initial temperature of the calorimeter water. Whenever I'm taking a temperature, I want to wait, make sure it's not adjusting anymore. So I'm taking an accurate reading. And it looks like it's pretty steady at 21.5. So initial temperature of calorimeter water is 21.5 degrees Celsius. Next, we need to take a look at the metal cube. We need the initial temperature of the metal cube. That is not something we can measure directly, though. We can't stick a thermometer right into the middle of that metal cube. But it has been sitting in this boiling water, and we know that heat transfer would happen between the water and the cube until they reach an equilibrium, until they are the same temperature. So we can measure the temperature of the water and know that the temperature of the metal cube is the same. So temperature of the water should be at 100 since it's boiling, and when I look at the thermometer, it is at exactly 100 degrees Celsius. So that means the initial temperature of the metal cube is 100 degrees Celsius. Now I'm going to transfer that, move this first into the calorimeter. Put the lid on right away so it's as insulated as possible. And then we're going to wait and make sure we really are taking a good, accurate temperature, that it's not rising anymore. As the hotter metal cube is moved to the cooler calorimeter water, heat is going to transfer from the hotter cube to the cooler water, again, until they reach the same temperature, until they're at an equilibrium. So when we take a final temperature of the calorimeter water, we know that's the final temp of both the calorimeter water and the metal cube. Looks like it's still climbing. As we wait, you can think about sources of error, anything that affects our data collection, affects our final results, that makes them less than accurate. For example, this assumes that no heat is lost or gained from the environment. Is that accurate here? Could some heat be lost during our transfer? Could our calorimeter not be perfectly insulated? So is there some heat transfer between the calorimeter water or the metal and the environment? Are there other sources of error involved in this lab as well? Still climbing, we're at 26 right now. Okay, our final temperature was 30 degrees Celsius, so that's the final temperature of both the calorimeter water and the metal cube. So record that in your data table. Last piece of data is the mass. The mass of this cube is 270.5 grams. So go ahead and use that data, do the calculations, and identify this unknown metal number 2.